So 1.7, absolute value inequalities and linear inequalities. And linear, first, linear and absolute value inequalities. Yes, indeed. Okay, so let's start with a easy situation, like 40 on page 203. This is a review from a previous course, but I'm showing you everything from scratch. Like 5, quantity 3x, 3 minus x, less than or equal to 3x minus 1. Hopefully we can finish this. We have, I see we have 15 minutes left, so maybe we can finish these two types. So 15 minus 5x indeed equals 3x minus 1. We eliminate parentheses first, absolute value, distributing, yes. So now this is a habit of mine. I prefer the variable on the left as frequently as possible, but you don't have to. So when I move 3x, I get negative 8x, and when I move 15, I get negative 16. Very good. So now we have to divide indeed by negative 8. Very good. But there is a problem. Yes. We have to switch the inequality symbol. So let me just refresh my memory, and please look at this. Is 1 less than or equal to 3?
Yes.
Let's suppose it is, right, everyone? Mm-hmm. Good. Let's suppose we want to multiply both sides by negative 2, and you should ask me why, and I'll say I have no reason. But I'm making a point. 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. Can I still keep this inequality symbol? Is negative 2 still smaller than negative 6? No. So that's the reason why every time we multiply or divide both sides of an inequality by a negative number, we have to switch the inequality symbol. Should I write this law, or can you, or do you want me to? So let me repeat. When we multiply or divide both sides of an inequality by a negative number, we switch the inequality symbol. When we multiply or divide both sides of an inequality by a negative number, we have to switch the symbol. Switch the inequality symbol to the reverse one. Or if you can just say, we reverse the inequality symbol. Okay. I like to look at one with fractions to make sure that no one will ever be afraid of fractions again. Ever again. Okay, so this is still a linear inequality. Oops, no one can see this. Can you? Oh, what is going on? My why is it okay? So I see 3 fractions, and you will give me the least common denominator, which is not the greatest common factor, but the least common denominator. Not the greatest common factor or a factor, but the, I'm sorry? Indeed. The least common denominator is 12. The smallest number that is divisible by 6, by 1, and by 12. Is that okay? Good. So we multiply by 12 over 1, multiply by 12, multiply by 12 over 1. Remember, we don't multiply. We simplify. So I'll simplify by 6. And I'll simplify by 12. So, can anyone dictate the new inequality? Do not distribute, because I want everyone to see what's happening here first. Yes, please. Talia?
You said don't distribute?
No, because I want this step, I want everyone to see first.
So would it be 2
Yes?
times 4 x minus 4?
Very good. Yes, we can multiply this, just don't distribute. That's good. And excellent. That's all I needed for now. Okay, I need to put my tent up. Sun is in the way. Okay, so now we're back to what we just covered, which is 8x minus 6 plus 24 going equal to 2x minus 1. And 8x plus 18 going equal to 2x minus 1. Remember, we have to combine like terms. Also, now we move terms around, and I get 6x greater or equal to negative 19, x greater equal to negative 19 sixths. We want the interval notation. How do I get the interval notation? And also for the previous one. On the real line, here's 0, negative infinity to infinity. And this number is negative 3 point something. I don't care for units. It's somewhere here. So this, the reason that I use the bracket here and a parenthesis here, first of all, infinities are unknown. That's not a number, it's parenthesis. Bracket is given by the fact that there is an equal symbol there. So the interval notation, x in the interval, so x is found in the interval, bracket negative 19 sixths, comma, infinity. For this one, we have the same thing from 2 to infinity. So x in the interval, 2 with a bracket, infinity with a parenthesis. I know you've seen this before many times, so this is not new. Okay, now I would like to discuss the absolute value inequalities. There are only two. We're going to look at the simplest possible situations first. And let's see what we come up with. This says find numbers x whose distance from 0 is what? Less than or equal to 2. Can anyone give us numbers whose distance from 0 is 2? 2 and? Where will I find, I have two options. Where will I find the numbers with distance from 0 less than 2? In between 2 and negative 2, negative 2 and 2, or a second possibility, away from 0, then 2 or negative 2. One more time. We have two numbers whose distance from 0 is 2 and negative 2. It's negative 2 and 2. Where will I find numbers with distance less than 2? In between negative 2 and 2, or outside?
0.
Of course, in between. So this inequality changes into this inequality, hence into interval notation this. So this one is the called in between. In between. In between. Now, what about this one? For this one, I see cell phones, and I would like to see what is it so important. Okay, so this one has two options, remember? So we cannot include anything in between now. We have to go to the further away and further away, which means x greater than or equal to 2 or x less than or equal to, indeed. But this one, the interval notation for this one has to have the union symbol. Union. Union symbol. This one, I start with the second one, negative infinity, negative 2, and 2 to infinity. See the difference between these two? The first one can be presented as a chain. Very easy to read. Yeah, that's the solution. I'm done. The second one requires to solve an inequality less than or equal to negative 2, and a second inequality greater than or equal to 2, and then put the solutions together. Totally different. This will be the end of this chapter, but I'd like to practice. Let's look at each type of problem. 80 on page 203. Let's illustrate. 5, the absolute value of 2x plus 1 minus 3 greater than or equal to 9. And I know you will say it's not cleaned up. You have work to do before you even identify which category is it. Is it the first type, the nice, easy one in a chain, or is it the second one that requires work, more work? So let's clean it up. Tell me what to do to clean this up. Very good. So then 5, 2x plus 1 greater to 12. Very good. So 2x plus 1 in absolute value greater to 12/5. Now I'm in the position to identify which type it is. Is it this type, the nice one in between, or is it the more difficult one with the outside? Yes, I agree. It is the most difficult of the two. So we have two options. We have 2x plus 1 and 2x plus 1. What will you say? Remember, it has to be greater than or equal to 12/5 or less than or equal to negative 12/5. You cannot include anything between these two. That's not for this inequality. So greater than or equal to 12/5 and less than or equal to? Very good. You cannot include anything between negative 12/5 and 12/5. So we move one. We get 2x plus 1 greater than or equal to 12/5 minus 5/5 is 7/5. Oh, I should have not written the 1 again. Like I just subtracted it, didn't I? And then divide both sides by 2 or multiply both sides by 1/2. Yes. When you multiply by 1/2, both sides, that's the easiest thing to do. You get x greater than or equal to 7/10. And now the other one. You subtract negative 5/5, right? So 2x less than or equal to negative 17/5. Same thing. We multiply by 1/2. And then get x less than or equal to negative 17/10. But now the solution has to have the union. Very good. We start with this one. Very good. Negative infinity, comma. Very good. Union, 7/10, infinite. Okay, we have 3 more minutes. I'd like to choose one more. So 1.6 and 1.7 have to be finished by Wednesday, so we can move on with functions and make sure that we can have our test. I'll look in a minute and see when it's scheduled. Okay, let's say 64. 3x plus 5 in absolute value less than 17. So now it's completely cleaned up. There is nothing, no steps that I need to perform here. So I just have to identify whether it's the nice one or the one that I have to work harder. It's the one in between, of course. It's less than 17. So negative 17 less than 3x plus 5 less than 17. It's the one as a chain that can be solved. The two inequalities can be solved at the same time. What will be the first step? What do I need to get rid of first? What do we need to get rid of first? Remember, we have to solve for x. I see you're all packed, but I still have 1 minute. Yes, we have to subtract 5 from all 3 sides. So negative 22 less than 3x less than 12. Excellent. We got rid of 5 first. Now, what do I need to get rid of? Very good. So we multiply or divide both sides by 3. So negative 22 over 3 less than x less than 4. And this is the interval notation. You will be asked to present the interval notation. Negative 22 over 3, there is no equal symbol, so I have to use a parenthesis. And 4, there is no equal symbol. And because this can be confused with an ordered pair, I will say that x is in that interval. And now the